Good morning, AP Physics students. This is Tuesday, March 31st. You should have got an email that there was no school Thursday or Friday this week, so your teachers can do some more training. And then you guys have a full week off, spring break. And then when we come back, we're coming back virtually with an online bell schedule and all kinds of interesting changes as we function as a fully online school until May 4th or possibly longer. So settle in. All right, so we're going to continue with momentum, and we're going to do an actual momentum lab. We're going to do it. We're going to do a momentum lab. We're going to take data, we're going to do a graph, we're going to use a virtual simulator, and actually, this is a lab I did last year virtually anyway, so this works out perfectly. It's equipment. There is equipment I could buy for this lab that I'm looking to buy pretty soon, but kind of works out well that we did it virtually last year. So this should work out just fine. Um, we needed to go over some vocabulary because it's been a while since you've used some of these words. So the first one is moment of inertia. Moment of inertia is the mass of spinning objects. And since spinning objects, their size has a lot to do with how difficult it is to spin them, which mass is really a measurement of how difficult it is to move you. For instance, since it's actually the summation of mr squareds, for a disk that's solid, it becomes 1/2. But if you're hollow, since all your masses are at the same radius, it looks more like that. Why am I talking about all this? Well, because we're going to spin an object and then we're going to add mass. And so by adding mass, what we're effectively doing is we're causing moment of inertia to go up. All right, so what else are we going to be measuring? Well, we're going to be measuring how fast it's spinning, or its angular velocity. So I'll remind you that we tend to use radians per second in here. Radians per second is what we're going to be using. And then angular velocity is just change in radian or the change in time. It's just how quickly it's rotating. And we're thinking that these two things are going to be related to each other. As we add mass, it'll probably slow down. But let's see if it'll work out. The next slides talk about the lab a lot more. This is just a vocabulary slide. All right. So in this experiment, I'll go ahead and read through it first. In this experiment, we're going to be observing the behavior of a rotating object when we drop mass onto it. So here's kind of the experimental setup that we'll probably have at South High School in the near future. If an angular momentum works like linear momentum, then our rotating object will slow down as we add mass. Because basically you're going to have more mass that's spinning, and if momentum is conserved, that more mass is going to have to spin less for it to be the same. So what we're going to see is we're going to be adding mass, and which will change the I value, because you'll notice this equation here with angular momentum. Momentum, it doesn't have mass, it has I. So what we're doing is we're adding mass, but that's going to cause I to increase. And so what we'll be doing is we'll be measuring how fast it's spinning based on I. And as you can tell from this graph of how your data should look, as I increases, as we add mass, it slows down. And the graph looks like it's a graph we probably haven't seen too much in here. You math kids will recognize that as 1 equals xy, or basically constant equals xy, or in this case, wi. So how do we figure out what that slope is? Well, we're going to need to put it into a form, because that's the idea. If you look right down there, oh, well, that question mark is actually the angular momentum. How on earth are we going to figure out what that is without just reading it off the simulator? Well, if you rechange this formula around like this, it shouldn't be too hard to figure out how I did that. Basic algebra step of dividing everything by I. Well, now I can put it in y equals mx plus b, and I can solve for the slope of that graph. And the slope of that graph is that value right there. That's the idea behind the lab. So all we need to do is take data on w and I by increasing I and measuring w. All right, to do that, you're going to need a simulator. So check out how you get the simulator. All right, so the easiest way to find it is to just to go to Google and search for PhET angular momentum. I have it on another page, the page with the lab. That's the easiest way to find it. I'll drop you a link on E2SD, so just click that, even easier, since you're going to be online anyway. Once you open up the simulator, it does require you having Java. I don't think that works with Chromebooks. It does work with everything else, basically. If that's going to be an issue with you, we'll figure this out. I think most of you have access to a Windows or Apple computer at home. So that should be fine. Email me. If not, I'll figure it out. Maybe I'll find another simulator. All right. But this is one we used last year. I'd love to just use this one. This is very important. You have to change it to radians. By default, it's on degrees. So I'm going to grab my highlighter here. So make sure you do this step. Incredibly important. People didn't do it last year. Messed things up. Okay, so once you've done that, once you've opened angular momentum and set it to radians, here's the cool part. You're going to need to give this thing a spin. You need to pick a velocity and then just press go and then don't touch that again. You'll see that it's spinning. And then if you play with the platform mass dial, you'll notice that it speeds up or slows down. Never, ever, ever touch that again. The idea is that we are going to be taking data as if we were spinning the object and then adding mass. And you never go back and like reset. You never touch it and rechange the speed. You'll simply have it be at a speed and then we add mass. All right, so basically, yeah, that's the thing. Set a speed, and then your first point of data you can gather because it'll tell you what the I is and what the speed is, and then this is cool because you would know how much the I value increases there. But here we have an actual dial here that we can go ahead and increase the platform mass. Don't make the platform hollow. Just increase the platform's mass. And then the idea is that you'll be able to read the new value of I, it should change, and the W value should also change. And taking your 5 points of data is pretty fast at that point. You just basically slide that slider to 5 different, this one here, you can slider type to 5 different values, grab them, and that's it. That's the lab. That's your data. But you're going to be doing some graphs, answering some questions. So we'll go over the next slide and take a look at that. Go ahead and erase these. Okay, so I have these directions on a specific handout, but what I would like you to do is to actually produce those two graphs. Yes, you do have to produce them. You can graph them on a computer if you would like to. That's fine. Don't be emailing it to everyone. You all have to do your own virtual graphs. You might be hearing some baby crying in this video. Sorry. It's pretty often around here. And so yeah, the basic idea is you need to actually take down your data. So I would make sure to be recording all this as you go. Make sure you don't forget to write down anything. We need to record our constants. And then you need to build these two graphs basically with your data. And then find the slope of the line. Pretty straightforward so far. And then the last thing you need to do is answer these questions down here, which kind of speak for themselves. Tomorrow, I will, well, actually, when we come back from break, maybe we'll chat about these. We'll have like a little class discussion. I would really like to do that. So make sure you get this lab done by after spring break, I guess, because we will definitely be doing a discussion. Maybe I'll even try to call on some students and see what they have. So that should be very interesting. But yeah, hopefully this works out great. You do need Java. You got to install it. If you don't, it should work fine. Try not to worry about the security things with Java. As long as you aren't going to a bunch of weird old websites that require you to run Java, you're fine. This website is fine. But yeah, I'll see you guys in class after spring break. That's kind of the plan. And Luke says hi. I need to go give him some milk or something. All right, see you guys.